Good afternoon and welcome to today's webinar titled Understanding Volkswagen's TDI Diesel Technology, brought to you by Volkswagen and Motor Age Magazine. I'm Larry Silvey, Editorial Director of Motor Age and SearchAutoparts.com. First, I encourage you to review our extensive diesel coverage on our website, motorage.com and SearchAutoparts.com. Also, I want to mention this presentation will be archived on motorage.com/VW Diesel so that you can replay it at your leisure as well as share it with your colleagues. Today, I am fortunate to have two of the industry's leading diesel experts with me. They are Dan Plans, Volkswagen's Technical Resource Specialist, and Tony Martin, Motor Age's Diesel Technology Expert and ASE Master Tech. Welcome, Dan and Tony.
Hi, Larry.
Hi, Larry. Good to be here. Good. Well, thank you for being with us. Our topic today is one of increasing importance for technicians. Undoubtedly, with the favorable attributes that diesel-powered vehicles offer, you're going to see more of them on the road and more of them in your shops. American motorists are waking up to the fact that diesels deliver up to 40% better real-world fuel economy, 20% fewer CO2 emissions, and unparalleled performance and long-term value. To make this presentation even more pertinent for you today, we ask that you play a role by answering some important polling questions about today's topic. Additionally, I encourage you to submit questions to us during the course of today's discussion so that Dan and Tony can answer them at the end of the presentation. Let's get started with our first polling question to see who's in our audience today. What type of business do you represent? Number one, are you a general repair shop? 2, a European specialist? 3, independent VW specialist? 4, VW dealership? 5, dealership other than VW? And 6, other. So let's just take a second and, put your, please click on which one you are. Again, what type of business you represent, and we'll have the results of that poll momentarily. And here we are. What type of businesses? General repair, 28.1%, European specialist at 3.2%, independent VW, 4.4%, VW dealership, 11.8%, and dealership other than VW is 1.2%, and something other than any of those is 51.4%. Okay, if you want to be prepared to handle this growing market niche, you need to be armed with some expert knowledge. This webinar was created specifically to help bring you up to speed on TDI diesel technology from Volkswagen, a leader in diesel-powered vehicles. All right, Tony, why don't you get us started here? We have a number of topics to cover on this subject, so please outline them for our audience.
Yeah, thanks a lot, Larry. This webinar is going to cover a fairly broad range of topics. We don't have enough time to get into real heavy specifics, but we're going to start with service information. And if you're looking for specific factory VW service information, where to find it, how much it costs. We need to touch on safety, especially concerning the common rail application. We're going to talk a little bit about compression ignition and the trends in terms of compression ratios and so on. There's also an evolution that's taken place in terms of TDI technology, and we'd like to give you an overview of what the milestones are in TDI evolution. Also, the newest TDI is a common rail motor, and we're going to talk about some details on that, including a little bit on the V6. And then the service tips are going to relate specifically to coolant, motor oil, diesel fuel, the sensitivity of these motors to specific coolant chemistries and motor oils and so on are something that Dan and I are going to be discussing and fairly, fleshing out fairly well. And then finally, what to do if your TDI is misfueled. These motors are getting quiet enough that people are forgetting their diesels, and a brief explanation of what needs to be done in those situations. So next slide, Mike. So for those of you who need detail on VW service information, it is all available online, the same stuff that's available at the dealer. And the portal is called Irwin. And you see the web address there. The good news is that, well, the bad news is you got to pay for it. The good news is that you don't have to pay for a lot of it if you don't need it for a length, any length of time. So if you just need 24 hours of access, $35 will get you that, and you can buy it all the way through an entire year if you like for a subscription. But that is the dealer level factory service information available at Irwin. Next slide, Mike. Now, there's another path to get to this service information, and that's through www.vwparts.com. Now, there's a lot of stuff available there. Okay, you can get to Irwin through vwparts.com. You're going to have to register, same way as you registered for this webinar. Name, email address, and that's all there is to it. At that point, there's a lot of free stuff that's available for you at vwparts.com. And amongst them is the fluid specification and capacity chart. And those are absolutely invaluable, especially concerning vehicles that are just off warranty and back to about 1999. There's some excellent information in there concerning the coolant, motor oil specs, capacities, all that stuff. It's available in PDF. It's all free. There's also VIN decoder, tire fitment guides, and there's also some excellent technical training videos for those who are interested in a little more information on what's going on with VW diagnostics and so on. Those are also available at vwparts.com. Next slide. So Dan, tell us a little bit about the safety issues that we want to keep in mind when we're servicing TDI motors.
Excellent. Glad to do it. I know this slide is a bit of an eye chart, but safety is something that we all need to be incredibly aware of. First of all, the TDI system deals with very high fuel pressure, upwards of 2,000 bar, meaning 29,400 psi, because a bar is equal to 14.7 psi. The lines, they must not be open with the engine running. I know some old school diesel thought for diagnosis and diagnosing misfires used to be crack lines open. Avoid this at all costs. As in any solvent, chemical, or otherwise, avoid contact with skin. You also want to handle connections with care, make sure they don't get nicked, damaged, bent, otherwise. Prevent fuel spillage. Install only clean components and clean the area before you even deal with such components. Another slide yet to come. Always put sealing caps. Never leave the fuel system open to the atmosphere for any length of time. Not at all. Always put a sealing cap on the end of it. High pressure pipes in some instances may be reused. You always want to check the latest repair manual information. Although any signs of cracks, distortion, or otherwise, make sure you replace those. Also ensure that people with pacemakers don't lean over the engine compartment. There's extremely high voltage under there. Also, when replacing any injectors, all the clamping pieces, any clamping pieces should also be replaced. And as Tony stated, for more information, you always want to seek advice of the repair manual. You can do that through vwparts.com. Moving on, we have a brief introduction to compression ignition engine. Unlike gasoline engine, compression ignition requires much higher combustion ratios, anywhere from 16.8 to 24 to 1. This high compression is required to heat up the fuel source enough to make it ignite. Now, the trend has been actually to lower the compression ratio, I think, for most manufacturers when it comes to diesel because of the formation of NOx. Some earlier diesels had much higher compression ratios. More modern diesels are running off actually lower compression ratios.
Now that in turn, Dan, as far as direct injection with gasoline goes, what's the trend with the compression ratios on those motors?
They can either stay the same or be elevated. Just like diesel, when it comes to direct inject gasoline engines, most manufacturers elevate the fuel pressures pretty darn high.
For the compression ratios?
No, the fuel pressures.
Fuel pressures, yes. No, I agree.
So, I don't know. I think they've probably been increasing the compression ratios, but I don't have the numbers. I want to say anywhere from 10 to 1 to 11 to 1, roughly. I don't know. Don't have the numbers in front of me, Tony. Good question.
Yeah, you were saying, though, that those are also turbocharged motors, too.
Correct. Yeah. Not, the smaller displacement ones are. Larger displacement engines may not be, the 6-cylinder stuff, 8-cylinder stuff, but definitely 4-cylinder stuff tend to be going more turbocharged.
Okay. Now, we're talking about direct injection here. In the previous generations of Volkswagen diesels were not direct injection. They were using a pre-combustion chamber.
Correct. And we can talk a little bit more about that as we come up into the different variations. We'll kind of walk through the progressions of our diesel engines to show you how we got to where we are now with the common rail.
Very good. Okay, next slide. Now, the TDI is a fairly famous, becoming progressively more famous as a trademark. It's basically turbocharged direct injected is what the acronym stands for. And this is VW and Audi's name for their diesel technology. Leading up to this, they were using pre-combustion chambers, and as of 1998, the TDI was brought to conception here, or brought to light. And since that time, the TDI has also become famous in Le Mans racing in Europe. So the 24 Hours of Le Mans for the first time was won by a diesel-powered race car that was powered by a Audi TDI. So the TDI name is getting famous, and we're here to talk more about that.
Let's first take a look at one of the first variations of TDI, the ALH. The ALH was similar to our earlier versions of diesel engines, and by the way, we're very proud of our diesel heritage. Volkswagen's been in the diesel business for many, many years. The ALH has a central injection pump. The injection pump is used to create high pressure. It also controls timing by controlling the beginning of injection period. This engine was with us for a pretty good length of time, probably between 1998 and 03 or so. So it was kind of a mechanical injection pump, electronically controlled.
Okay, so that was the one question I had, Dan, was the injection pump itself did have some level of electronic controls on it then?
Correct, and basically all designed to help more finely or more precisely control the beginning of injection and also the quantity.
Very good.
As time progressed, the next variation of our TDI engine was a pump-inducer. Pump-inducers ran about 2003 to 2005, and the main difference with the pump-inducer is the high-pressure pump was broken down and individualized per cylinder. A lot of people know this as a unit injector engine. Each injector was responsible for creating the high pressure required, but they were electronically controlled to manipulate timing and beginning of injection period, also electronically controlled for total injected quantity. You can see the pump-inducing engine in the fuel system architecture. It has a lift pump in the fuel tank. That pump is responsible for basically maintaining a good quantity of fuel through the fuel filter and up to what we call the combination pump or the high pressure pump as it's listed in the slide. Although when we're talking high pressure pump, we're not talking about 1,000 bar or so. This, although it's a high pressure pump, is mainly responsible for volume. And you can see the line connected to the main rail where the injectors are. Each of the injectors are basically creating the extremely high pressure that we use to inject into the combustion chamber.
What kind of pressure are we talking coming from the high pressure pump that's seen in this slide, Dan?
It varies a great deal, give or take, but I want to say it's just, a couple of bar. Always look it up. But in comparison to the hundreds or even thousands of bar the injector makes, it's relatively benign in a way. The amount of pressure that comes out of it, the volume is the key.
Okay.
It needs to maintain a good volume to those unit injectors, because anytime you're injecting something in such a high pressure, the amount of quantity you give it is critical. You definitely don't want it to starve.
Was this the first TDI that used an electric pump in the tank?
Good question, and boy, that's kind of calling me on the spot. I want to say that it is. Most of them, with the mechanical pumps were actually act as a suction pump and drew the fuel through the fuel filter rather than having any means of pushing it through the filter.
Okay. So this, I'm curious about what sorts of problems, and we can talk about this when we get to the common rail, what sorts of problems we can run into with a failed electric pump in the tank. We can talk about that in just a little bit.
Sure. Well, let's continue with a closer look at maybe the unit injector. The unit injectors for the individual cylinders are actually driven off a camshaft. So they're mechanically driven yet electronically controlled. Now this electronic control could be magnetic, it could be a solenoid, or it could also be piezo. So there's a couple of different variations of it. Always look for the latest repair manual information on these. One hint on these is when it comes to a pump inducer, make sure you always use the correct oil as well, because there's a lot of pressure involved in activating these injectors. All right. Let's move on to the common rail.
What year was this, Dan, that the common rail was introduced?
The common rail came in about 2008, and it's running to present time. A couple different variations of it. The 4-cylinder variation of the common rail is different than the pump inducer because the high pressure pump now is not integrated into the injectors, but it's moved before the rail. So the common rail basically is common in the fact that it provides high pressure to all the injectors. So that's, I guess, somewhat how it got its name. But this particular engine we're extremely proud of. It's an award-winning engine. It's really doing well for us. It performs well. Most people sitting behind the steering wheel of a car with this engine in it almost can't tell it's a diesel. So we're really proud of this.
So on this one,
go ahead.
Well, I was just going to say on slide 15 there that common rail is not an unusual concept in diesel technology, but the big difference here would be basically the high pressures we're talking about here. And so we're running all the way up to almost 30,000 PSI at times with these, as far as the fuel pressures go on this particular motor, right?
Yeah, it can be that high. I mean, it can be up to a couple hundred bars. So with pressures that high, you can really get precise atomization and precise quantities injected. The critical thing, though, when dealing with pressures so high is how quickly things have to happen. As you can imagine, the injectors have to operate very quickly. With that kind of pressure behind it, if you hold it open any length of time at all, you're getting a pretty hefty volume of fuel.
So these injectors are responding very quickly then?
Absolutely. Some of them can respond. They're responding multiple times per combustion cycle. With some of the earlier engines had both a pre and a post injection. These can inject up to 5 times or so per combustion cycle.
So next slide, Mike. There we go.
The 6-cylinder is very similar to the other slide, although obviously the torque and horsepower rating is quite a bit different on it. This also, we're really fortunate. This has been a wonderful engine for us. People that drive this definitely like it. They fall in love with the amount of torque that it has. It's a great alternative to people that are used to driving big V8s and such. So it's really been good for us. All right. Moving on. Similar to the slide that we took a look at with the pump inducer, the basic fuel system architecture on a common rail contains a lift pump in the tank. From there, the fuel is pumped to the filter. From the filter to an auxiliary pump, usually somewhere under the hood. After that is the little component up on the top that does kind of a pressure sensor and a screen, then going into the high pressure pump. Now that high pressure pump is responsible for delivering the pressure to the common rail. Pressure's, like we said, up to a couple hundred bar. Then the injectors are plumbed off of that.
For a couple thousand bar.
Couple thousand bar. Yeah, there you go. So 20,000 PSI. I mean, I just do the math. It's mind-boggling.
The electric pump there, Dan, if TDI has a underperforming or failed electric pump, is that going to stop the car?
With the auxiliary pump under the hood, the car will probably continue to operate. Maybe the next key cycle it may not start. The lift pump in the tank, I bet the auxiliary pump would probably suck enough fuel through, but, you know, all that kind of stuff has a lot of variables involved in it, and I think anybody that's been around diesel any length of time knows how sensitive they are to cavitation and air in the fuel system. That would almost be a speculation, but I think it would operate okay if the one in the tank was failed, but can't guarantee it.
Underperforming at best, right?
Right, underperforming at best, not functioning at all at worst, right? So that'd be something you definitely want to keep an eye on. Right. Another thing we can take a look at is the glow plug, because part of what makes this engine so special is its ability to monitor and basically have a closed loop operation of the fuel system. To do this, the glow plugs are basically outfitted with a pressure sensing membrane, and this membrane can monitor combustion pressure per cylinder. And it's just, the thought of that, to me, is a miracle.
And that's in real time, too, right?
Exactly, in real time. So it's a running compression test at best, but it goes a lot further than that, because if you can check the exact combustion pressures based on quantities and VIPs and everything else going on, just imagine how finely you can control the emissions, the power, the performance, and everything else.
So you're able to balance individual cylinders then.
Exactly right. You know, smooth running for a diesel is very, very important, and smooth running, like most cars, misfires are detected off a speed sensor, right? So changes in speed on an engine speed sensor kind of lets the lets the car know that there's an imbalance. With a pressure sensor in every combustion chamber, I think you know a lot more accurately.
Then I imagine you could also have it adjust on the fly for varying cetane ratings and fuel and so on?
Yeah, I would imagine that, with all the maps and the adaptability that the modern processors have, it's mind-boggling at how well they can adapt for adverse conditions. Although a little bit later we'll show a slide talking about, minimum recommended cetane ratings and such. All right. The next thing we can take a look at is the turbocharger. Now, the turbocharger on our diesels is rather unique. We tend to not use a wastegate. We don't blow off pressure. But our main goal is to create pressure at a lower RPM. To do that, we have a variable vane turbocharger that basically can change the opening that exhaust gases flow through to drive the turbine. Now, obviously, the smaller the opening, the higher the velocity of the exhaust gases. The higher the velocity, the higher the turbine speed.
So in this case, Dan, if we rotated those vanes clockwise, we'd be closing the nozzle then.
Right, and right about now it's closed pretty far. You can see that the opening between the turbine and the vane is pretty thin. So if you rotated them counter or clockwise, it would actually be opening them up, right? And you'd have a bigger gap between the turbine and the vane, which would be slowing the velocity of the exhaust gases.
So is turbo lag a thing of the past, Dan?
Yeah, pretty much. With this design of the turbo, they can really, really control the RPM of the turbocharger. It's not like it used to be where you feel it spool up midway in the throttle. This thing is really great right off the bat. You need this sort of unique technology because, heck, diesels run under much lower RPM than gas engines. And I think you said it best when you saw it about the, in effect what you have with this, right? And
Which is that?
You mentioned that in effect you have a smaller turbo at lower RPM and a bigger turbo at higher RPM.
Yeah, that would be the beauty of it, is that you could, overall displacement could be, it could be a large turbo, but you can make it respond like a small one.
Right. So this has been really great for us having this variable displacement turbocharger.
And you guys are basically, like for instance on the 2-liter, that'd be a single turbocharger, Dan?
Correct. Single turbocharger, and then some of the bigger engines, we go with dual turbochargers, one per bank. Nothing series, anything like that. I know, it's usually one per bank. We're going to do more than one.
Okay, that's good.
All right, exhaust after treatment. Now this is a real eye chart, and basically this gives you some sense of how complex exhaust after treatment is. And I tell you, this is really, really amazing. If you consider the reduction in output, in particulate output, we're extremely proud of what this common rail and this exhaust after treatment's been able to do for us. But one unique element is the EGR system. A lot of times turbocharging an engine, you have trouble running EGR to reduce NOx. Well, this has dual EGR paths. One EGR path actually directs exhaust gases that have been cleaned and the particulate's been removed back through the impeller of the turbocharger, so exhaust gases are actually boosted. That allows us to maintain EGR all the way across speed and load ranges whenever it's needed.
So that's the low pressure loop you're referring to there.
Correct.
And then your high pressure loop, you've got a throttle valve that's there. Can you talk a little bit about what the throttle valve is for?
Well,
on the lower left?
The throttle valve is basically, which throttle valve are you talking about?
J338 I'm looking at.
J338 can do a number of different things, and it functions in a number of different circumstances. One great thing about that is vibration when you shut the engine off. A lot of times when you shut the engine off, a diesel, because of its high compression ratio, really vibrates as it comes to a stop. You shut off the intake air, she doesn't vibrate so much because it's not developing any compression. So it can do a number of things with that particular throttle valve, but you need to understand that it's not a gas engine. This throttle valve is not controlling engine speed.
Yeah, so the default position on that would be wide open then.
Correct.
And then you've got an EGR solenoid, and that's on the high pressure side, as opposed to an EGR throttle.
Yeah, it's more of a throttle.
Okay.
They call it a solenoid. It could be more of a throttle or more of a either or. It just regulates the exhaust gases, very similar to any other EGR valve. So that particular circuit is very familiar to most automotive professionals, and that, it's just pretty much standard EGR.
Now, can you talk a little bit about the exhaust throttle valve? That's top right corner, J83.
Well, basically that's in play. It assists the particulate filter. It manipulates exhaust back pressure and can just help facilitate all this great exhaust after treatment we have. So all of these things working in conjunction with one another really make this state of the art as far as the emission of particulate output. It's really amazing.
Now, tell us a little bit, Dan, about the role that motor oil plays in the operation of the particulate filter.
Excellent. That's really a critical point, Tony, and I really appreciate you bringing it up. The motor oil that is recommended for this is considered a low-ash motor oil, and we need to make sure that we use nothing but this motor oil, because of the fact that use of anything else or even overfilling can contribute to ash that could be collected in the particulate filter. Now, we were kind of kidding around a little bit, Tony, and I was telling you a little bit about my dad. Mm-hmm. My dad has always had his favorite motor oil, and that's all he ever put in any car or truck that he ever owned. And I tell you what, he would roll over right now to hear me saying that you have to use this motor oil in this car. But
right.
I tell you what, I'm here to caution you. You really need to use this oil.
Now, the ash that's actually being generated that winds up staying in the filter, that's being caused by what? There's additives in motor oil? Additives in motor oil that are not burning during a regeneration?
Not really sure on the question. I just know it's the wrong stuff, and we need to use the low-ash stuff. The exact chemical action or reaction that causes it, well above me. I'm a fairly simple guy. If they tell me that this is going to create too much ash and to use the right stuff, I've learned over time that I should probably do what they say.
Sure. Now, what sorts of symptoms or problems would a driver run into if they were using the wrong oil and indeed were collecting ash in that filter at a greater rate than they should?
The particulate filter, you get warning lights on the dash. So
do you have a mill light on?
Yeah, they'd have either a particulate filter light indicating that it's having trouble regenerating, MIL and or a glow plug light.
And then it says in the first line there, Dan, that the diesel particulate filter ash loading level must be checked. How is that going to be done by a technician?
It's done, basically we can monitor it through the pressure sensors in the exhaust system. So we have a pressure sensor before and after, we can monitor loading.
So there's going to be a certain pressure drop that takes place across that particulate filter?
Correct, and you can see if it's backing up. So it's done electronically. There's no serviceability if that's what you're getting at. You don't really have to service it.
I hear you.
Yeah, yeah.
Very good.
All right.
Let's talk about coolants and things here.
Sounds good. Oh, we're still talking about oil.
Let's talk about oil.
Season. We're also talking about oil here. Make sure that you go to that www.vwparts.com. That'll help you with some capacity charts up to 06. If you need to get a subscription to Irwin, do so by all means. My advice, even though, like I said, my dad probably wouldn't like hearing it, is use the right stuff. You need to make sure you're using the right stuff. Don't overfill it. And that's true for anything anymore, right?
Pretty much.
Yeah. Next is cool.
Yeah, I was going to put in a plug for VWparts.com again and the fluid capacity charts that are there.
Right. Right.
And we talk about that in this slide, too. Tell us a little bit, Dan, about the progression in coolants here over the last little while, just in a quick overview.
Well, coolants have changed quite a bit, and I'm sure they're going to change even more in the future. Moving through all these different variations, and I tell you what, people tell me, and this doesn't matter even what they're dealing with, what make, what model car. It's all about the green, the pink, the yellow, the orange, or whatever color it is. But I struggle greatly discerning differences between, minute differences between colors of coolant. We've moved from a G12 coolant to what they call G12 Plus, which kind of went from a pink to a more violet color. Then it changed to a different variation of violet in G12 Plus Plus. One thing is just my same advice for my dad would take place for coolant as it did for oil. Look it up. Use the right stuff. If you need to get to that VWparts.com, make sure you go there by any means and make sure that you're using the correct coolant. We can no longer afford to be mixing this stuff because of the kind of problems that it can create. Let's talk for a moment about diesel fuels. Now, diesel fuel requirements are basically, it requires ultra-low sulfur diesel fuel. And some of the questions coming in are how much bio, and, 5% bio is the max that's allowed. Wax appearance point, that's another method that fuel is rated. You can see that it's -7 degrees. 4 point. Another thing is gasoline should never be added to the diesel fuel. And our cetane rating minimum is 45. And you want to make sure that you buy fuel from a reputable fuel dealer. Tony, in our discussions in the past, I kind of told you what my hints always were for my family.
Yeah, tell us about that.
Well, when they drove a diesel, I always told them, if you're going to a fuel station and you don't see a stain of diesel fuel on the ground, that station's probably not selling very much diesel fuel. So you probably want to get to a place that's turning the fuel more often. So my advice is look for one that's really turning the fuel. You don't want to buy diesel fuel that's been sitting in the tank forever because the place is not selling.
Now, the ultra-low and the issues related to that, there's probably still just ordinary low-sulfur diesel available, 500 part per million sulfur. And what sorts of issues would a customer have if they were to actually use LSD fuel instead of ULSD?
That's a good question. I got to believe that it's going to lead to something, more than likely something the engine management system could monitor, and it would probably show up in the way of an MIL. If there's any doubts about what kind of fuel you're buying, you need to consult your fueling station and make sure. Now, I know in my particular area, any diesel pump I come up to says right on it it's ULSD. It has a picture of nice green trees on it. It lets me know right away that it's ultra low sulfur fuel. If you came up to a pump and that pump was not a very modern-looking pump, and you were unsure of what was in it, I would caution against using it.
Good.
Yeah.
Any other additives at all in the fuel? Because there's other stuff aside from gasoline that people can use. Imagine, what are your recommendations?
Basically, I don't recommend the use of any additives in it. Anything other than the repair manual may suggest. I would always refer, this can change. We talked about how quickly things change, Tony, and, as of this moment, definitely not cut with gasoline. And when it comes to additives, make sure that you consult the repair manual.
Very good.
All right. Now, also, there's a one note on there. We have this next slide about misfueling, and this I would be really cautious of. If you know the thing hasn't been started, drain it and refill it. You'll probably be good to go. If the engine's been started, well, that opens up a whole Pandora's box of how long was it running, was it driven, how much load was it under, how much speed, what temp. What I would do at that point, if the engine has been run at all, is refer to your repair manual. You want to make sure that you follow what the latest repair manual information tells you to do in that instance. Gasoline can definitely damage these high-pressure components because it doesn't have the same lubricity that diesel fuel does. So you want to be extremely careful not to run these things if they've been misfueled.
Yeah, the car's still going to run.
Yeah, it may not. I mean, it depends on how much. If you had no diesel fuel in the system at all and put gasoline in it, I don't think it'd be too happy. But
right.
Most people tend to fuel up quarter a tank of gas. It could run, and it's definitely the amount of fuel that's in reserve and the filter and everything else is going to allow it to start and idle for a while.
Right.
Yeah.
Now, of course, this is getting to be more common over time as these common rail motors especially are becoming quiet to the point where people are just plain forgetting their diesel.
Right. And the other end of that and the other argument you could have to that, it'd be people that tend to purchase diesels like them very much, and they purchase them because they are diesels. So their awareness of the fact that the car is a diesel car is great, but if you lend the car out to somebody, that's where problems come in. So that's kind of an interesting thing, yeah. All right.
So all your bleeding procedures and all that stuff that you need to know is going to be on Irwin then.
Correct, and it varies. It varies greatly. You want to make sure that you follow the correct procedures when dealing with anything that's misfueled.
Good stuff.
All right. Well, moving on.
All right, Dan and Tony, you guys are doing a great job here. In fact, judging from the number of questions that we're getting, you've certainly, struck a chord with our audience today. And right now I'd like to jump back in and ask a couple of polling questions if I could, and then from there we'll move on to answering some specific questions from our audience. Our next poll question is, what percentage of the vehicles you work on are Volkswagen? Are they 0 to 2%, 2% to 5%, 5% to 10%, or more than 10%? If you could just quickly check one of those boxes, we'll have the results up for you in just a moment. Again, if you would, answer the question. And here we have. We see that percentage of vehicles that you work on are Volkswagen. 46% was the highest, and that's 0 to 2%. Next was more than 10%, 29.2%. 2% to 5% was 19.3%, and then last was 5% to 10%, 5.3%. Thank you. And if we could move on to the next poll question, a very quick yes or no. Before this webcast, were you aware of www.vwparts.com as a resource for your shop? Would you please make a selection of either yes or no, and we'll have the results of that for you in just a moment. And here we go. Looks like most people were not familiar with vwparts.com at 72.8%, and a pretty good percentage, though, 27%, a little more than 27%, that they were. All right, now we're going into some of the questions that have been coming in. They've been coming in fast and furious, and there's if we could go back to what you were talking about, Dan, about coolant. You talked about that quite a bit. Could you tell us what kind of problems are created by mixing different types of coolant?
Sure. There's a number of problems, and I remember early on when G12 first came out, I actually did an experiment on my own. Obviously not in an engine, but I mixed the coolant and then heated it. And I tell you what, it turns to a dark mud-like color and consistency, and it can really foul things up. So other things that can happen, I got to believe, is affect the way it's able to deal with electrolysis and create electrolysis. But a lot of things can happen, and cooling systems, I tell you, they're one of the more underrated systems in a car. You really need to take care of them because they're a lot more complex than people think. So that mud light, what I've seen.
You know, Dan, you said something the other day that I just loved, and that was the life of the car is directly proportional to the love of the owner.
That's
well put.
Yeah, that's the truth. And that's the truth for anything, not just cars, right?
That's true. Absolutely.
All right, good question.
All right, very specific question here on micron level. What micron level is recommended for the fuel filter?
I recommend the factory fuel filter, and I know you're saying, oh, that's just another factory guy talking. But I tell you what, we're pretty proud of our genuine parts, and I guess the simple answer to that is I don't know. Always using factory parts, I've never had to speculate as to what the micron filtering capability is of that, how many microns it'll filter down to. So apologize for that.
Oh, no. I think it's really good advice. I mean, I use it myself. Understand that here's a question came in that person has an understanding that the fuel in Europe is a higher quality than it is in this country. Well, first of all, is that true? And then what kind of effect in our fuels are we going to have on the performance and drivability issues by using I guess what they're saying is a lower grade fuel?
Well, I wouldn't, the way I'd characterize it is that, generally speaking, the cetane ratings of the fuels in Europe are much more consistent than they are here in the United States. And one of the really cool things about the PSG, or the pressure sensing glow plug that Volkswagen is able to use, for the closed loop combustion control, is that it can adjust for the varying cetane ratings. So that's where people have gotten really smart about all that stuff, and they're making the technology work better for the conditions that they're presented with, sort of thing. So some of that's being overcome by technology.
All right. Here's a question on underperformance electric fuel pumps. Would an underperforming electric fuel pump possibly starve the HPST enough to cause failure?
That was yours, Jim.
Yeah, that's a good question. I'd be speculating to give you any answer on it. It depends. Like I said, it's more about volume. I think columns of air going through the high-pressure pump is really detrimental to it because it's not being lubricated. Not really sure that if reduced volume without the indication of or without injecting air or cavitated fuel in through that pump would be that detrimental to it. So there again, I'm going to have to say that, that it's definitely a possibility if that pump was cavitating, it could cause some damage to it, but if there was good steady, if it was underperforming but there was still a decent volume of fuel there, it would be properly lubricated and cooled. So I know that kind of sounded like a politician there for a minute, didn't it?
Yeah. Well, the follow-up to that, someone had a quick question about pressure. How much pressure does the lift pump have?
Right. It varies. It varies depending on, year, make, model. That's a specification that you definitely want to run by Irwin if you were testing it. Number one advice, though, comes to a lift pump, comes to any pump for that matter. Check it for volume and check it for pressure. We all tend to try to shortcut things and just do a pressure check on it and still wonder why it doesn't work. So make sure you check it for volume and check it for pressure.
And another question, does the high voltage come from a collapsing magnetic field in the injectors?
No, the high voltage is actually needed to operate the piezo injectors. So the voltages on those, unlike a solenoid, the voltages are much higher.
Now, there is a flyback voltage or voltage spike that takes place when the injector is de-energized. But do you have any idea at all? This is DC volts that they're using on those injectors, right, Dan?
May not be.
Okay.
Could go below a zero amplitude.
Interesting.
Yeah. So, not necessarily.
Don't get near it if you got a pacemaker.
Right. Yeah. Yeah. I mean, you probably don't want to wiggle check it or probe it with a test light either.
Good call.
So yeah, you want to make sure that that's true with anything anymore, right? Unless you know what you're dealing with, you don't want to poke or prod it with anything. I tell you what, information's your best friend. Figure out what you're dealing with first, then figure out what kind of instrument you need to diagnose it.
All right. What makes this system go into regen?
That's a good question, and it's definitely calculated out by the ECM, and there's probably a ton of things involved. But probably, I would say, oversimplifying it incredibly, it's difference in pressure sensors. So it knows what's going on based on the pressure sensors.
Okay. Are the hot EGR gases cooled like they have been in earlier models?
Yes, they are. There's all kinds of EGR coolers on this thing, and some of them are actually regulated, not just the EGR is not just run through a cooler. It can either run through it, not run through it, or half of it runs through it. It's getting a lot more sophisticated than it used to be with EGR because of its impact on combustion pressures and such.
And it's all liquid cooling, right, that they're using for the EGR, Dan?
Yes, sir.
Okay, a couple things about vanes. Are the vanes controlled like oil, like power stroke? If so, oil changes will be critical. Is that correct or no?
Our vanes are either solenoid or vacuum module controlled, although I'm not really positive what the power stroke vanes look like. And I'm assuming
they're similar. The vanes themselves are similar, Dan, but they're, in the case of the 6-liter, for instance, it's actually a piston operated with engine oil that's changing the vane geometry.
Right. So the answer is no, but I still say that oil changes are critical, though, but any turbo engine.
Dan, our last question, does ULSD reduce vein sticking?
I don't think it impacts vein sticking that greatly. I think it more impacts exhaust after treatment. We've had the variable vein or variable displacement turbocharger before. I mean, pump and dudes has had them, and heck, ALH has even had them. So that turbo's been around for a long time, and we've used it even before the onset of ultra-low sulfur. So I don't know. I can't really answer that, but I don't think it does.
Seems to me you nailed it, though, that it's going to have a much bigger impact on the operation of the after-treatment system, right?
Right. Exactly.
All right. Well, thank you, Dan and Tony, for providing timely, useful, and, all this information on TDI technology. Great insights and practical advice on this subject. I think it's really going to be helpful to those who want to follow in your footsteps, as diesel experts, and you certainly are that. And thank you very much for being with us today.
Thanks, Larry.
Welcome. And again, for our audience, I want to let you know that that was Dan Plant, Volkswagen's Technical Resource Specialist, and Tony Martin, Motor Age's Diesel Technology Expert and ASE Master Tech. And before we go, let me remind you again that you can replay this entire webinar by going to motorage.com/VW Diesel. And tell your colleagues they can do the same. We hope they will do that. Also, we want to know what's on your mind with regards to this topic and others. You can do that by joining our community. I urge you to do that. It's very easy to do. Just visit workshop.search-autoparts.com and follow the simple directions. And last but not least, I want to thank all of you in our audience for joining us today. I am sure you have a much better idea of this technology and why it's important to you. So on behalf of Volkswagen and Motor Age, this is Larry Silby, Motor Age Editorial Director, wishing you great success in building your diesel business. Have a great day.